Purdue University worked with the American Society of Civil Engineers to create a science-based simulation to show the impact from the inside out. Purdue decided to model the first impact to show how the American Airlines 767 penetrated the North Tower. They began by modeling the World Trade Center complex, 7 buildings on a 16-acre plaza in Lower Manhattan. This would be a living model of the North Tower from the inside out. Purdue used original construction blueprints, photographs, and construction data to create a wireframe World Trade Center structure. Every column, girder, and beam had to be in the correct place. They also created a scaled 767 jetliner, an aircraft with a weight of 141 tons, including 10,000 gallons of fuel. To model what this fuel load would do upon collision, Purdue launched fluid-filled aluminum cans to simulate an airplane wing impacting a steel column. A thermal camera captured the impact and fluid behavior. This raw data was also added into the sequence. Thousands of man-hours and 21 days of computer rendering were needed to show a total of 1 second of actual time. It took 2 years to complete the project. This is the final Purdue science-based simulation. The jetliner crashes into the 96th floor, severing a number of perimeter columns in the structure.
And you see, I can tell you quite honestly that we didn't fudge. The broken columns in the facade, by calculation, coincide almost exactly with those that were broken, so that our model was correct.
The simulation shows the impact from many different angles. Entry. Internal destruction of supporting columns. Disintegration of the jetliner. Atomizing of the 10,000 gallons of fuel. And the fires that attacked the steel network that supported the building.
You see, we're going to have a source of heat here that covers almost the entire core. And that starts heating the columns, which are unprotected. There is now no insulation on them. And it starts heating the beams. See, the beams, in a manner of speaking, provide restraint at the edges of the columns, which are loaded axially in the vertical direction. So it takes fuel and oxygen coming in, of course, to add the fire. The temperature here could have reached beyond 1200 degrees Fahrenheit. And that doesn't melt the steel, it softens it. And that softening makes the restraints on the columns not as effective. And the column itself becomes soft. So it bends to one side. And of course, there is a vertical load on it. That takes care of it. So it goes away, and that's what happened in that building.
Purdue's findings confirm the report by the National Institute of Standards and Technology that widespread fires initiated by the jet fuel weakened the steel columns and brought down the towers.